OneX Developer Podcast.
Hey everybody, welcome back. It's OneX Developer Podcast. I'm Colin.
I'm Brendan.
And we have a very special guest today. Adam, I didn't ask you how to say your last name. It's
I try to
Brudzewsky?
avoid saying it because it's too difficult. Something like that.
Okay.
Brudzewsky, I think.
Okay. Where
Don't
are
try
you
to
from,
repeat
actually,
it. It's
Adam?
fine. I'm Danish. I'm from Denmark, but my grandfather came
Okay.
from Poland, hence the last name.
Okay, cool. We're both located in the American Midwest in Kansas City. I don't know if you know where that is. Most people don't. That's okay. So, Adam, do you want to tell us a little bit about yourself?
Sure. And I guess in the context of what we're doing here. So it really, I should say, begins with my father more than me. It's sort of a more interesting story. And my father, for fun reasons that we could come into if you really want to, ended up working at IBM's development labs in the international IBM in the late 60s and until the early 70s. And there he was exposed to what eventually became APL, or maybe it was APL, called APL. It probably was called APL already at the time. And it was exposed to Ken Iverson, who was we call the father of APL. And he eventually left IBM and set up his own consulting business where he did APL programming for various companies around the world. And I grew up with that. My father was working from home. That was, I guess, unusual at the time. And this is a long time ago. This is in the mid and late 80s and early 90s. And he would show me, even as a baby, I would sit in his lab. I would look at what he was doing, and he would write me little programs that could create graphics and sound written in APL. And I came along with him, and my mother came along as well to conferences. There were these international APL conferences every year. Not far from where I grew up was also one of my father's competitors, some other APL consultants, and met up at the APL conferences, and they had a son my age and a daughter my sister's age, and so families became sort of close at the same time as being in competition with each other. And so I very much grew up in that APL environment. And for me, there wasn't really a time when I started learning programming or started learning APL. It was sort of just a language, like you learn how to speak your normal human languages, but this is the language I would speak with a computer.
Yeah. That's interesting because you'll hear programmers sometimes say like, "Oh, I'm a native C developer or a native Python developer or something," but you really mean it when you say it.
Yeah, it really was. And apparently, I don't remember this anymore, but apparently, I attended my first APL conference just before I turned 2, and they wanted me to demonstrate some user interface that they had written in APL that was supposedly so easy to use that even a toddler could use it. I missed my presentation because somebody offered my parents to get some orange juice for the baby, and they brought me a screwdriver instead of orange juice, and so I slept through the whole thing. But they definitely got in with from the very early start. And I remember like very early flashes of doing things with the computer. But I didn't really do anything serious until I was, I guess, maybe 8, 10. And then I wasn't on my own with the APL until I was 12, I think. Then my father would just plop me in front of the computer and say, "Here, just have a go."
I think that's such a cool way to grow up. Just have it like, I don't know. It seems like when you learn it that young, it's just like deep in your bones.
Yeah, it has upsides and it has downsides. The upside is that I know the language very well. I think I have a good feeling for uh, what kind of extensions or ideas people have that make sense or don't fit in so well. It does require some effort for me to put myself in the place of a learner, especially somebody who comes from other programming languages where things in APL seem weird. For me, it's what's different from APL and other languages that is weird.
Yeah. Yep. Just whatever you grew up with is the normal one.
Yeah, exactly. Like people who are used to speaking English don't find English grammar and spelling strange, but for a newcomer, it's completely insane. Like, there's no rhyme or reason to anything.
I guess we should say, we didn't say at the outset, this is kind of a follow-on to our APL episode where we used the Try APL website. Adam, you made the Try APL website?
I didn't quite make it as such as I participated in it. It has gone through multiple iterations, and I have had my hands deep inside it in its latest iteration. I go and fix up things. So it's not entirely me. It's really a whole team of people there. I think you read the names of the people when you looked at it as well. So it's a joint effort.
And so, yeah, I had some questions there about, so there's a company Dialogue that you're a part of. You're the head of language design.
Yes.
And so Dialogue is an APL interpreter, and that's what's kind of like the engine behind the site. Is that right?
Yeah, that's correct. I can explain a little bit of what the APL ecosystem world looks like. So traditionally, APL was exclusively a paid for language. There were a small handful of big vendors of it that survived the initial turmoil where there was a lot of different vendors. So in the 70s, every computer manufacturer, there wasn't really a standard. Today we have like the PC standard basically. All the hardware is compatible with each other, but every manufacturer of computers, they had to supply software that was applicable to their hardware setup, and every computer manufacturer, with respect for themselves, would also supply an APL. So they all piggybacked on IBM's design, and slowly the computing scene sort of got crystallized into just a few architectures that we still have today, and some of them are even on the way out and have died lately. So there's just a couple left. And so IBM made the PC and started from the beginning of the 80s. And their APL then became sort of the standard APL. And there were a couple of companies that then made sure that their APL was very much in line with IBM's APL. Some of them even so eager to do so that when there was like a specification document, then they would jump to implement that faster than the giant juggernaut of IBM could go ahead and do it. So they would publish first, and then IBM could change the standards after the other ones published, and then you have the incompatibilities. That sprung out of this in the early 80s as actually it was called Dyadic Systems, but they implemented an APL for the Zilog processor. That's, you don't really hear of them anymore, but if you have like a I think it's Texas Instruments graphing calculators, they still use Zilog or Z80 or Z8000 processors. So that was the original thing that Dialog did. And Dialog was a small upstart company, and it was more nimble in doing things, and came with all kinds of inventions. But it wasn't the behemoth of IBM, and it wasn't a well-established American company like the company behind the flavor called APL Plus. There's another one called APLX. Over time, all companies but Dialog sort of faded into just supplying their existing customers with whatever they needed and not making much of an invention on the language itself. Whereas Dialog slowly Just kind of extending the language, adding some features, adding more integration with various modern tools. And that continued until, I guess, the late 90s or so. And that's when, and up to the 2000s, that's when you could begin to really see a contrast where dialogue had sort of kept up with the times. The other ones had faded into sort of not an oblivion, but like they're stuck on old technologies. Dialogue adopted Unicode, and you might think, we're going to answer this question later, how in the world do you do APL without Unicode, with all those special symbols, right? That was a real problem. And dialogue went 64-bit eventually, and embracing online things and code in text files. You might also ask, wait, what? How do you keep your text, your source code if it's not in text files? But this is how it was. Right? The APL is so old, it comes from a time when files didn't exist. There was no file system. There was no real operating system. There was a task scheduling system on the computers, and APL was the operating system, which is why you don't maybe feel so much in TriAPL, but if I show you a real installed system, it sort of feels more like a operating system shell, because originally that's what it was. And one indication of this is that the command to close down APL isn't exit, but rather off. Because if you close APL, you turn off your system. That's it. There's nothing to go out to. Right?
Yeah, that's wild.
So dialogue, I don't even know if dialogue sits on the majority of APL vending today. I don't even think so. But definitely is leaps and bounds in front of any competition. IBM recently sold their APL division, like they divest themselves of everything these days. And the company that took it over, they said they had all kinds of big plans, but they don't even sell the product right now, so we don't know what's going on. There's APL Plus that is still alive, and they realized that they had gotten so stuck in their old technology they couldn't even upgrade anything, so they decided to rewrite everything from scratch, and that of course can have quality issues. They are working on it, of course. Maybe it will turn out well. APLX, the company behind the APLX, Micro APL, they did some side business where they helped people migrate between systems, and that side business grew so much that when they realized the amount of effort you would take to redo the APL division, because it's gotten so behind technologically, they saw that it simply didn't pay. So they closed down the APL part and just do migrations today. The company is doing fine, but they're not doing APL. So that really puts dialogue very much front and center, even though it's not such a big company. We have got some big customers, some of which I can speak about, some of which I'm not allowed to speak about. And dialogue then sought me out, knowing that I'd learned APL from Little, from my father, and asked if I'd come in and work for them. So first I did some consulting from afar, and then I moved closer to the head office and got more and more involved with everything, really. And I'm close with the leadership, and I'm very much the language enthusiast in the company. And so eventually was made this officially head of language design. It doesn't mean I'm like a, what do you call it, benevolent dictator for life or anything like that. I can't make decisions on what the language is going to be, but it's my job internally to push for enhancements and suggest and model and describe and present at conferences and so on about language enhancements, especially in the core language.
That's such an interesting story, because all that is just so different from how it is now. I mean, I feel like typically now it's some guy comes up with an idea for a language, puts it on GitHub. He is the benevolent dictator. He just does whatever he wants. And then, all that other stuff about like different interpreters, there's none of that. There's just kind of like one way to do it. And yeah, it sounds like just a completely different world.
Well, that's the world of the old programming languages, right? APL is way old, right? Nobody was even dreaming of the precursor to C when the APL came out. And the only languages that are from back then are Fortran, COBOL, Algol, Lisp, I guess, but like it's only really the syntax that has survived and not any particular implementation. Whereas I can take a program written in APL from 1966 and just run it on our modern day interpreter, and it will just run.
That's
The only
amazing.
only things that need correcting are if they're like system calls, like to some special services, those kind of things. But those are super easy to correct, and I have done it. It actually works. So
Yeah.
How different are the different flavors of APL?
that's a very good question. So that depends a bit on how wide you go out. It's an interesting question, even on what is APL. How do you even define APL? Because it's sort of a language continuum in various flavors. As I said, everybody went by IBM in the beginning. So that core, until about 1980, that core of the language is pretty much universal. But there's very little difference. Actually, one tiny difference that does exist is that IBM made, and that's what they had until recently and that they've sold off, something called APL2. It actually has one tiny little syntactic incompatibility with old APL. Whereas, for example, Dialog does not have that incompatibility. So Dialog is more compatible with IBM's original than IBM's current or latest offering is. So, but those are very small things that you rarely bump into. Then each vendor has added their own things, especially when it comes to various, we call them system functions. They are like, there are not these glyph-based things. There are named entities that services and extra tools that are there. Dialog is unique in having added quite a few glyphs, like core language features. And of course, those are just not there in the other flavors of APL. The basic array model is shared almost universally. That when I spoke about the plethora of implementations from every hardware manufacturer, that was all the in what we could call APL 1. It wasn't actually called that, but they were matching what IBM did, the original APL, and that was had a very limited array model. It's called, which we can go into further what exactly that means. Once the new array model was rolled out, that one is pretty much, that one is shared between everyone except actually Iverson himself broke with IBM, went and founded his own company that today is called J Software, but was called Iverson Software originally. And they had a different view of how to extend the language. They didn't succeed business-wise on that. Iverson went and made a new programming language, different from APL. Or maybe it's just a flavor of APL. That's up for discussion. The original version of it was called APL \?, but later it was named J. And J was originally implemented. The actual code was written by Arthur Whitney, and Arthur Whitney was then a protege of Iverson. Also, Roger Huey joined with that. Was also like a very close student of Iverson's. And Arthur Whitney went on to create a special business version of APL for Morgan Stanley that he called A. That was then extended to A+. That still looks like APL at first glance, although A+, and it was called Sharp APL, the one that was that Iverson had designed for, that was handled by IP Sharp. That doesn't exist anymore, but was bought up by Reuters and closed down. They have a different array model, so my thing might look the same at first glance, but there are some edges that where things are quite differently. And Arthur Whitney then went on to discard the idea of using special characters in A and A+, made a new language based on that, but with a completely different array model called K. And yeah, as you can see, APL is like one letter names for things and like keeping things terse. And he managed to get quite rich on this. Eventually, it became a company today called KX, which doesn't actually market K, even though their name indicates this. They market another language that's very similar called Q, that has less symbols and more keywords, but it's essentially just a cover on top of the more terse language underneath. So there's you can't really say at what point is it not APL anymore, sort of a fluid thing. But if you look at Q and you look at, say, dialog APL, they don't look anything alike. But occasionally you might see a pattern that is actually the same. So, for example, to sum a list of numbers is plus slash in both APL, in any APL, and also in K. In Q, it might work, but they prefer you write the word sum instead or something like that. But
yeah, that's interesting. I mean, that was one of the things that Colin and I both said during the video was like, I feel like this would be easier to get our hands around if we had keywords instead of symbols. It's interesting that some people went down that route.
They did. It's an interesting proposition. I think the people who have enough experience with APL-like languages, they don't want that on that anymore. So you'll be hard pressed, I think, maybe people should contact you and say that I'm wrong if that's the case, but I think you'll be hard pressed to find a real Q language geek. Because anybody who is, or as they call them, Q gods, anybody who gets to the sufficient level of the language Q will prefer to use K. They don't want those keywords. They just want the terse symbols. And you can also see it when somebody worked for a dialog for a while, Marshall Lockbaum, he published a language called BQN, which is the name APL, where you increment all the letters by one and make a calculation mistake.
Oh.
So
I didn't notice it.
Well, it's 112 added to APL gives BQN, no, otherwise it would be BQM. And we had a working group internally at Dialog that, especially just to vent the frustrations of the young kids in the company that thought like, hey, yes, APL is great, but it has all these warts just collected over the years. What would APL look like if we could like start over from scratch? And then Marshall was the implementer of that. Eventually he left the company and then he continued that on his own. And that uses Unicode symbols. So even though there was a choice of you can do whatever, but still choosing to use special symbols, even more so, I would say, than traditional APL does, because APL eventually, over the years, added some keywords for control structures and things like that. BQN has nothing of that. And there is, of course, the problem, how do you enter those symbols? And once you get enough of them that you can't memorize or fit them on a keyboard anymore, it becomes a bit of a problem. Somebody, Kai Schmidt, made a language inspired by BQN called Wiwa, which also uses special symbols. It uses even more special symbols than any other APL, than BQN or APL does at least. But it has a very different syntax. It's stack based rather than being like more mathematical formulas. And it does use the special symbols, but you can write your source code using words. And if I remember right, it will change your source code, replacing your keywords with symbols as you compile or something like that, or run your code. It's a bit interesting.
Yeah, that's an interesting idea.
to change that like that. So I think we can conclude that symbols are the right choice for people who stay with it.
Yeah,
I was
There's
curious.
a learning curve.
Yeah, there is certainly a learning curve. But actually, so I had one of the things I was going to ask about was JBQN and Wewa. So I'm glad you talked about that history a little bit, because I was kind of confusing to, like, from the outside looking in, like what are all these different things like going on here? But I'm curious. So like when you're writing APL, really two things. First of all, do you use like key bindings to enter all your different symbol or glyphs?
Oh yes.
And then secondly, in your head, are you like saying the name of the glyph, or are you almost like, does your brain almost just work in the symbols, right? Because that was something I struggled with. Like as I was writing it,
very good questions.
Trying to write it, I was like, okay, squiggle thing, triangle thing, array. In my head, it was like kind of hard to kind of translate,
Right. So traditionally, APL has been written using shifting keys. So actually, it was the case on the old IBM machines, the very first things that they replaced the lowercase alphabet with the uppercase alphabet, and the uppercase alphabet with APL symbols. So you use the shift key to write an APL symbol. So for example, if you write shift A, you would get an alpha, but there was no way to write a lowercase a, which is why ancient APL code only uses uppercase text, but it's not because the computers couldn't handle lowercase, but simply there was no way to enter it or store it at the time.
Oh, that's
Then people have gone on. Obviously, we can't do that today to take the shift key away from you. So
I'm
various
guy,
APL.
Like, why are you yelling at me? Like, I don't have lowercase letters. Sorry.
I mean, you'd be surprised. I mean, I have one customer that I help a lot, who apparently prefers having caps lock on at all times. I guess it just feels more familiar to him. So, but when he writes to me in chat, it sort of feels like he's shouting at me. So, various APL vendors have gone with various things, and all of it has upsides and downsides. Dialog traditionally on Windows uses the control key. On Unix and so on, it uses the Windows key. On Mac OS uses the Alt key, I think. There have been times when you could choose. APL Plus uses Alt as well. I can sort of switch back and forth, but I prefer having a shifting key like that. I currently use my right side Alt key, so on the right side of the space bar. Try APL, and also if you install the full system, you have this choice of using a prefix key as well. So it's not a shifting key; it's a key you entered before. So on Try APL, if you press the backtick key on a English keyboard, then you can press another key after that, and it would be corresponding to those systems where I have a shifting key, holding the shifting key to that. And I can't handle that, right? That's not immediate enough for me. I'm so used to expressing myself using these symbols that having to press a key sequence rather than a chord is simply too slow for me. So I can hold my Alt key and a Shift key and a letter key like right after each other. And that works for me. Backtick or any other prefix introducer key, that does not work for me.
I can see that.
I definitely think in the symbols, not in the names of the symbols. You will find if you listen to APL or speak with each other, they have to verbalize the APL symbols, that they will variously use the name of the symbol and the name of the functionality interchangeably. And they will tend to adapt the name that they're using to the exact domain they're working on right now. And this is actually pretty salient if you think about it. If you give a functionality a name in English, that pushes an agenda of using that functionality in a specific way. But you might be able to find other ways to use it if you had an open enough mind. If your mind is being artificially closed by the name of the thing, you might never realize that there are other possibilities, other things you can use. So an example that the prominent YouTuber on programming languages, Connor Heckstra, or Code Report, he brings up is in C++, they have something called adjacent differences. And it does exactly that. It calculates a difference between adjacent elements in an array. Only what you might not notice is that it can take another parameter of another 2-argument function, and it will use that instead of the default, which is minus. Right? The default is minus to take the difference between two adjacent things, but you could also do adjacent sum or product or anything you want adjacent. But the name that they gave it, adjacent differences, makes it so that even expert C++ programmers don't realize or don't think of the possibilities that you could use there. So another thing is the keywords you have for true and false. You very much think of them as truth values, not as numbers. In APL, as I think you saw also, that we use 1 and 0 for true and false. And by not limiting ourselves to thinking of them as truth values, but simply being numbers that happen to be in the output domain of Boolean functions, and comparison functions, and so on, then immediately we grab for the numeric methods to continue computation on those numbers. Whereas if they were true false values, you wouldn't think of doing numeric things.
Right.
So it's perfectly normal for an APLer to raise a number to the power of a Boolean. That might sound strange, but for example, sometimes you need a sign of something. So you need either 1 or a -1. And you do that based on a condition. So how do you map a condition to 1 and -1? Well, it's very easy. -1 to the power of the Boolean. Because to the power of 0 always gives 1, and to the power of 1 gives the number itself. So -1 to the power of 1 gives -1, -1 to the power of 0 gives 1. Now you map the Boolean to ±1. And you probably wouldn't think of that if you had the words true and false. Right?
Yeah, that's very true.
Yeah, well, I think in most languages, I don't think you even could, right? Like, you can't do if you have a primitive data type of Boolean, you can't do stuff like that. You can only do Boolean logic
You might
stuff.
get a type error, you're saying. Yeah, that's also a good point. Some languages allow it. I do it in JavaScript all the time. People read my JavaScript code and they think I'm completely nuts.
Yeah, if I saw that, I'd be like, what is going on here?
Yeah.
Yeah, but so when you're talking about they adapt it to the domain, are you talking about they speak of these things in terms of like financial functions or other kinds of business domains?
It could be that, but it could just be what we are talking about. So, for example, there's no I would say there's no Boolean type, but like numbers are numbers. Sometimes we need to work on the bits of a number. And we don't have any functionality in APL to directly work on the bits. So what we do instead is we'll represent a number in base 2, which makes it into a bunch of zeros and ones. Now, when the number is represented like that, then the take function, which you explored in your previous podcast in this, which takes the first few elements, it refers to the top bits. And you can give also a negative number as a parameter. Take the last bits. That would be the bottom, the least significant bits. Right? So I might express myself as if the take function is a function that selects bits from a numeric representation. Whereas if I'm dealing with text processing, and the exact same function now takes the first few letters or last few letters of a string, now I'm talking about the prefix or suffix of the word. Right? If the word begins with on, then negate the action, something like that. So if the prefix is, right, so it's a to prefix, or it's the 3 top bits, but it's exactly the same function, exactly the same concept. And that you cannot find an English name that is reasonable to cover all these different use cases.
Right. Yeah.
But the symbol is abstract, right? So I can map an abstract symbol to some action, to some pattern of behavior, and that works fine. There's no conflict because it's just an abstract symbol. And, you can even see that the world is sort of recognizing this, because if you look at your phone interface or even the interface in the chat system that we're using right now, they very much push symbols for actions and states rather than using words for it. Why is it that street signs in general we use pictograms and not words? Right? Because it's very easy for people to map real world situations and actions and problems to pictograms, even if the pictograms, technically speaking, do not describe fully what's happening. So the street sign for being careful because there are roadworks might as well be a pictogram for people playing in a sandbox, right? It fits just as well, but it isn't, because we choose to map it like that, and it's very easy for us to understand that. We don't get confused by it, even though it doesn't really in itself mean anything particular.
That's really interesting. That's a really good analogy, the street signs. I like that.
Yeah, it's blowing my mind a little bit. So one other thing I wanted to ask about. So I mean, you mentioned a little bit that you can talk about some of Dialogue's clients. I'm just kind of curious though, like what kind of verticals are people that are using APL in production, like what are they in? What are they doing with it? Why are they choosing it?
Yeah. So the number one reason, to be completely honest here, for using APL is having previously used APL. Right? Somebody started something in the 80s and they just developed it since then, and you don't want to switch technology in the middle of something. But often people are also very happy about the choice of APL, and it makes certain things easier. But it's very widespread. So APL is a very good fit for certain types of numerical computations, linear algebra, things like that. That's not what we see it being used for. We see it used for production planning, financial computations. It is used for, I would say, general purpose computing. Even people just have things they need computed. But our customers at Dialog range from huge financial companies that have where their main. I mean, I can mention this by name. There's a European company called SimCorp, actually a Danish company, that does portfolio management, and their main product is written in, or all the core logic of it is written in APL, and that's not changing. When they need new functionality, computing various things, it's very fast for them to implement all the mathematics behind it, because APL is very well suited for the mathematical parts of that. So, but the actual application runs on a dialog interpreter. There is, so in a completely different end of this, there is a one-person company, I think it is, in Denmark that that coordinates food distribution to schools and occasionally other institutions. So they have like an online ordering system with the parents going in and order what kind of sandwiches their children will get in school, and then it takes care of having it made and sent to the school at the right time. It's a full stack APL application, if I understand correctly. That's very different from that. In Finland, there's another one-person company where there makes a not a game, a simulator for ship navigation. So Finland has lots of treacherous waters with small islands and sharp edges around the coast. So they have huge coastline with islands, and they have a lot of patrol boats and military shipping and so on, and commercial shipping for that sake. So he makes a simulator for this kind of thing that simulates everything, wind and water moving and splashing on weather and ship types and engine types and the time it takes to spool up and stop and whatever, all those kind of things, and all navigation charts, everything. So it's a professional simulator. It's all just an APL application. It uses some library for actually drawing the graphics, some game engine, something. But all the computation, everything is just running a single APL program. Then there are some financial institutions that use APL internally. It can even just be as an internal calculator. There is a large American mining company, Metsim, that does mining and processing of mining products, simulation, and also both simulation and also, what is it called? It's called like a clone, like where you simulate the real world at the same time as the real world is happening, and then you compare the real world with the simulation. So if some values in the real world all of a sudden are very off, then you can like sound the alarm, something is going wrong. It's not what we expected to happen. Also just planning for various mining operations. So their whole system is also just one giant APL application that does all the graphics and diagrams and computations and reporting and everything. There are lots of different things like this, lots of different areas. So it's definitely used commercially, and it's not going away.
Yeah. So how do you do graphics in APL? Is there an APL library, or are they like dropping into something else?
There are a few different ways, and it depends on the exact APL. I have the most insight into how you could do it in Dialog APL. So on Windows, since whatever, forever, Windows 3 or something, there's been really, really tight integration with the WinForms system. So that's Windows' like old-fashioned native ability to draw graphics elements and interactive elements, so on. It's not really well suited for writing a game, but it's fantastic for writing business applications. Right? This is the same sort of system that Microsoft uses to make Office. And the only reason those applications look snazzy is because they paint a canvas on top of the application, but underneath you have like the old-fashioned buttons. And so Dialog has a very, very well integrated interface to this. It's not even an interface. Like, it's so integrated that you can't really tell where one begins and the other one ends. Like, it's you can directly in APL manipulate the various parameters of the GUI elements, and it just reflects real time. So, and being that it's an interpreted language, that means you don't really need like a form designer, because you can just build up your application, and as you can be suspended in a debugger, and as you're changing values, the application just changes on the screen for you. It's really nice. So that's some successful applications are written like that. There's the SimCorp application was originally like this. The SimCorp bought up a competitor that their application is written like that. It's front end. There's a medical system that's being used in Sweden extensively that I believe is written using this system. That's the easiest to get started on. That's on Windows only. On all platforms, since a few years back, we have a built-in component in the language called the HTML renderer. So it sort of acts like those built-in Windows GUI components, but it is just a Chromium browser, basically. Chromium embedded framework. And that's also fairly well integrated into the language itself. So you can use APL directly to manipulate some parts of that browser. So you can build up HTML and so on in APL, or use any library you want, and then you can push that to that browser, and you can use that offline. Or you could, of course, use exact same code and push through a web server. And we have an APL or various APL web servers as well that you could use to push to a browser. So, for example, what you saw in TryAPL, that is an APL server running behind the scenes. And the HTML you see that's obviously rendered in the front end is handwritten, and then it's just served by the server, and then there are callbacks between the front end and the APL server backend with some computation functions that take care of the interactivity. Okay. And then, of course, there is we have foreign function interface as well. So in principle, you could communicate with any graphics library you want. You just have to write the right incantations for doing so. There are various experimental things in progress. The problem that we have is, like everybody else, that by the time you target one graphics library, it's outdated, and everybody's using something else. So that's a bit difficult. Somebody fairly recently started work, or is almost finished working on what is it called? There's a Raylib. There's a library called Raylib that renders like 2D, 3D graphics and sound and so on. And he's written a very nice bridge that's almost done so you can write games and other things in Dialog APL with nice integration as well. Okay. So there are some possibilities like that.
I want to ask a little about that. Like, in some of the APL code examples I looked at, just like looking around GitHub and stuff, I wasn't totally clear on what kind of things are available in APL for like, does it have modules? Does it have libraries that can be imported? I wasn't sure like how to get external code, some other library into my APL code.
Oh, you're asking all the dangerous questions here. That is a very good question, and there's a good reason for that being confusing. We internally at Dialog are, as we speak, basically working on an actual module system. So there hasn't been one. There's some interesting reasons for that. One of them is that a lot of the things you would use a library for doesn't make sense to have as a library in APL. Right? If the name of the thing you need, any reasonably short abbreviated name for the thing you need, would be longer than the actual implementation right? Then why bother? Because then you just have to know what does this name refer to. Whereas if it's just written out in raw code, you can just see it does what it says, right? Its name is its definition. And once people are used enough to use APL and read APL, it's much easier to just see the code. And so traditionally APLers, rather than using libraries, they've just copied and pasted if necessary, or just rewritten
Interesting.
things. So there's much less need for libraries. On top of that, we have, as I mentioned earlier, these things called system functions. So we have a lot of very clever people working on the APL interpreter itself. And rather than writing like a standard library in the APL, they, in the implementation language, mostly C, they write some functions that are very humble looking. It could just be a short word. So any of these named things that come with the interpreter that are sort of vendor specific, many of them, they begin with a special rectangle symbol that we call quad. So for example, there's a function called quad CSV, which does, well, yeah, you guessed it, right? CSV files and CSV parsing and writing and so on. Anything you to do, not just with CSV files, but any kind of character delimited or fixed width column text format like that, it can do. So you don't need a library for that because it's all built into the interpreter. You don't need a library for web rendering because it's built into the interpreter. You don't need a JSON library because JSON input and output is built into the interpreter, etc., etc. Right? XML parsing. So a lot of the things are sort of batteries included, and even things that are not, it's not worth it to have a library because it's so easy to write things in APL. Like there is no library for splitting texts in the various ways you would want to do it, because there's so many different ways you could want to split the text. You would have meaningless names. You just write the few characters in APL, whatever it is you mean by splitting text. That said, as the world gets sort of more complex and built things upon things, we do need sort of modules, I think, at least, or some people think so. We also probably need some kind of repository for it. And there is something for dialogue called Tatan. So it's people like to make Apple flavor jokes on the name. It's pronounced APL, but since very long time ago, people have been making the word Apple jokes. So Tatan is a tart that made with apples. So it's a way to serve apples in a delicious way. So hey, this is how you serve APL modules, and it has various libraries. You can go, I think it's Tatan.dev or something like that, that you can find things and install it. But it's a little bit cumbersome as it is today, but it can be it does work.
This is a repo though, like CPAN for Perl or something like that.
Yeah, or npm or that kind of thing. So it's a collection of submitted packages, but there's also some code that comes with it that comes with interpreter that you need to sort of activate because it's not really finalized yet. But you can use that to then pull these modules in if you want. They're not really modules because we haven't defined what a module is, but we're working on that. Probably the next version or two will make a real thing. We'll probably have a built-in keyword called modules and so on to assist with this. And some people still swear by just copy and paste. So there's a website that I made out of frustration by always getting the same questions from people and how do you do this and that in the APL. So I made a website called aplcart.info, as in like tipping over the Apple carts, but APL cart, yeah, more of those jokes. And it's just a collection of little phrases and functions and so on, because everything is so compact in APL that it's barely worth it to set up a whole repository with a README file and licenses and whatever, not in order to give a single line of 20 characters. We still feel weird about that. And we do make repositories of dialog for various tools, but we often feel weird about all the circumstance necessary to give you one file with a few lines of code in it.
That's exactly what I saw.
it.
But yeah, on GitHub, that's exactly what I saw. Was the repo was like a dozen APL files that were all just a single line. I was like,
yeah. Yeah, somebody
you
told
do
me
every
about
now
the
and again
experience
hear
they
about
had
those.
with the
Sorry.
advent of code, where they went to look for solutions to advent of code, and so they found this one file, and they couldn't figure out which. That was back when advent of code was 25 days. And they couldn't figure out which problem was it that it was solving until they realized that it was all of them. It's one line per problem. Sorry, I cut you off, Sean.
Yeah, sorry. I was just saying, it almost makes you think about how, sometimes you hear about those NPM packages that are like, I think the famous one is like called is truthy, and it's just,
Yeah.
it just, tells you if it's true or not. And it's like, why are we doing this, guys? Why are we installing this? And it really, like, I think I like it, copying and pasting, which again, you talk about the age of APL. It's that, I think, before the days of package management, that was what you did, right?
Yeah.
And you're absolutely right. I mean, if it's just one line of code, like, well, there it is,
Yeah. It's also an interesting question of licensing, because can you even have a license or copyright on a single line of code that is like, if any reasonably educated APL would write pretty much the same thing, it doesn't really make much sense, right? You just, the time
Right.
to go and find those things, you might just write it over.
Yeah, that's an interesting, just part of its lineage, part of its history.
Yeah, though it's interesting because APL is sort of closely tied with the history of internet, pre-internet. So I mentioned before the IP Sharp company. There was a big vendor of APL before their line of APL sort of became a sideline and disappeared. And IP Sharp in the 70s and the early 80s, they were basically an online company. And they did have offices, but they had offices all over the world, and they were connected by phone lines and in something you would call internet. And they had email. It wasn't called email, but the system was called box or inbox, and they could send messages to each other. And they had instant messaging, and that's how they communicated. They were like paperless. They just, everything in the company was decided by email. And all these systems were written in APL. So it's not a foreign thing to APLers to be in contact with each other and share with each other. Traditionally, there have been a lot of APL publications, conference proceedings, newsletters, and so on. There's a bit less of that today. But even then, if you see somebody has written some code, it's not worth it to have them electronically send it to you. You can just type it up. So little, might as well.
So at this point, I almost wonder, like, is there any reason why I wouldn't use APL? Like, is there any area where it really struggles or just doesn't make sense?
Yeah, I think there are plenty of places you wouldn't use APL. I might sound like oh, APL is the salvation to every problem. It's there are plenty of things where it's not the right choice. If you're writing things that are supposed to run in the user's browser, then JavaScript or something that compiles to or builds on top of that is probably a better choice. If you need to write low-level things, then it's not the right choice. At least not anymore, right? I wouldn't write an operating system in APL, but you might write a model for one, right? Much faster to write something that acts like a certain system, and then you go and implement it in a low-level language afterwards, or even try to compile it. There are various efforts to compile APL to low-level languages. Then there are things that are very domain specific where there are already libraries to those things. So there you can interconnect with other things. So for example, we have something called Pineapple that allows you to use Python from within APL or use APL from within Python. So you could use Python libraries, but if all you're doing is just gluing together various existing libraries in Python, then there's no real reason to use APL as the glue language for that. That's just extra complication, and you go use that. You can get very good performance on certain things that APL is good for. But there are also things that APL is not good for. APL really wants you to use flat arrays of things. So if what you're doing is a lot of computation on single numbers at a time, and every new step depends on the previous step, so you can't parallelize anything, then and you're running tight loops everywhere, then you want to get some low-level language where you can tell the computer exactly what needs to be done. And APL is definitely not good for that either. But if you're doing things that are using like bit patterns to filter out things and so on, APL can be very competitive. There's sort of a joke that occasionally APL can be faster than hand-coded C, which is of course impossible because it's implemented in hand-coded C. So how can it be faster? But the problem is that, let's say you need to sort, and you're writing a C program. So a good C programmer might choose a sorting algorithm that seems reasonable for this problem and call it a day. Whereas an APL interpreter has had decades to implement every thinkable sorting algorithm and use heuristics on the data to figure out what's likely to be the fastest way to sort this data. Right? So the interpreter has all these different algorithms built in, whereas a human would not write all those different algorithms every time they need to sort something in any application there, right?
Yeah.
So you could see the interpreter as a library collection of algorithms that you just have access to with single symbols as well. And then there are very clever algorithms for certain things that are easily expressible with APL symbols that would require superhuman effort for to write in directly in the C, for example. So occasionally you can get very good performance, and many times you will not get good performance in APL. So things that are performance critical. I don't think I would want like a real-time control system for in aerospace to be written in APL. So it doesn't seem like the right thing. But modeling and flight planning and things like that, APL certainly has been used by say NASA, and I think JPL used APL at some point. And so for those kind of things, yeah, that's fine.
Yeah, that makes sense, that because arrays are so central to it, that, APL developers over the years have spent a lot of time thinking and really optimizing those algorithms related to array processing, like that.
Yeah.
Sorting.
I think one thing that you don't want to use APL for is implementing these so-called AI machine learning things, because they need absolute top performance on some very specific things that you rather use as much hardware as possible rather than software to compute. But modeling it and getting an understanding of how does it actually work, so it's not just a black box to you, but you actually build it up from scratch, their APL is really, really good because it has all the tools available for matrix computations that you need. Because really, all that we call AI today is just one giant matrix product over and over again.
I'm curious if LLMs are any good at writing APL or if they struggle.
They struggle. Why do they struggle is an interesting question that we can't tell really, because nobody knows what happens inside those black boxes, right? Yeah. But we can observe that they struggled in various ways. It's getting better. And if we take a sort of harsh approach and say it's all just canned phrases, then the comparatively less amount of ingested APL code leads to less ability. And that if it was Python and JavaScript, there was very little of, they wouldn't be able to write that either. That's certainly one theory you could have. In that case, just more APL code being available for ingestion would help. It's possible that the APL syntax is not very well suited for the way that the token generation happens.
I was wondering about that, yeah.
So it may be something to do with most programming languages sort of being unidirectional, sort of flowing from left to right in a way, whereas APL in a way can go both ways. That could be an issue. Another thing that I've sort of seen issues with is because of the Unicode symbols, the tokenizers get things all wrong. Like if they try to analyze APL code based on the bytes that are there, ignoring the fact that multiple bytes belong together and form a single symbol, then you get a lot of like gobbledygook. It doesn't make any sense, right? To try to predict which symbol should be, like, which bytes should be next to each other rather than which symbols. So that could be an issue as well. Another reason that's sort of my preferred one is that these AI systems are really not good at doing anything intelligent, but most programming languages have such a huge amount of boilerplate and repetition that people feel a huge relief by having all that being canned. But APL doesn't have that. You can't predict the next symbol in an APL phrase because there are a lot of different possibilities, each one of them be doing meaningful things.
Right.
Because it's just one symbol difference makes all the difference between various algorithms you might want to apply. And so there is nothing for this fancy autocomplete to complete. It can't. It has to ask you, so what is your intention? What do you want to do? At which point you might as well just write it yourself. And especially if the language is not very wordy, it's much faster to type something meaningful in an APL than it is to type in other languages. So this kind of code generation doesn't save me much. It will take me more effort to write out in English, to translate the concepts in my head to English or some other language, to tell the AI to translate it back again to symbols, when I might as well just write the symbols to explain what I mean. And you'll find the APLers using APL to communicate between themselves too. It's not just a programming language. And so if I mean something, though, sometimes I will speak out the APL symbols to colleagues to explain what I mean, because it's easier than it is to explain it in English. It's just a better suited language for communicating algorithms.
Oh, that's really interesting. Yeah, that you find it easiest to express it in APL itself.
Yeah, or pseudo APL sometimes. That's so it's interesting. You touched on that in your podcast, on the name APL being an odd name, and it might sound sort of like haughty to say, "Oh, it's a programming language," like as with no other programming languages. My theory, I haven't researched this, but my theory is that the phrase programming language wasn't actually used for programming languages in back then, when APL got its name. Whether they were called coding languages or machine code or whatever they were called at the time. There weren't very many of them either. And APL was, or the precursor to APL, Iverson notation, you could call it, didn't really have a name, was just a fancy mathematics extended by Iverson as a mathematics teacher, to be able to describe algorithms. Because mathematical notation, the way we have it in schools, is good at describing what is, but it cannot describe steps to do things. Like do this, then do this, do this, and then now you have the answer. Or certainly not looping around. There just isn't vocabulary. There isn't symbolism for that. So he made this rationalized mathematics with additions that allowed you to express algorithms. And then, only then came the idea that, oh, you might actually want to use this as a way to instruct a computer to do certain steps. That was a fairly novel thing at the time. So it could be a programming language, a language you use to give the computer a program of things to do. Do this, do this, do this. That's why the book was called A Programming Language, as a sort of a theoretical thing that, oh, this could be a programming language. And then when they needed a name for the language once it was actually implemented, which was quite different than what it was in the book, somebody got the idea that, oh, first letters of that book, APL, so we'll just call it APL. So APL as the programming language does not actually stand for a programming language. Rather, it's inspired by the name of the book, a programming language.
Was the book, and was it a teaching text? Or did they use it in classrooms, or?
No, it was what was it really? It was more of a statement. It was from Iverson himself saying that, oh, this could be a programming language. But that language looks very different. Like an experienced APLer today will struggle mightily to understand the language used in that book. So then Iverson worked together with some of his friends and colleagues to create a language that was actually suitable as a programming language based on the original language that he was using on blackboards. And that was, the original was like a 2D language. It was drawings on the blackboard with small letters and bold letters and whatever not. It looked much more like mathematical formulas, and they linearized everything. So the language is a single line of code and only using a smaller set of symbols. And that's what became the programming language that's APL today.
Oh. We're we're running a little bit long. If you have time, Adam, I had a
Yeah,
couple of
I've set
questions I
aside
wanted
a
to ask
couple of
about.
hours for this, so it's fine.
Okay, great. I wanted to ask about like some of the specific glyphs, I guess. Like
Mhm.
we talked about in our podcast, and you mentioned in your email, like J versus I for imaginary numbers. Is there a history
Yeah,
there, or
I
what is that?
haven't heard an actual like authoritative answer to that, but I have my own speculation on two different sides why that is. Firstly, as you mentioned as well, that engineers prefer J over I, and but also if you look at the syntax for it, the APL syntax for a complex number is not the syntax for complex number you see in the normal math textbooks or even in certain programming languages that can handle it, right? It's not A plus B times I. Rather, it's AJB.
Mhm.
And so I would say if using the letter I there would sort of be confusing. If it said 3I4, you might think, oh, what is this? 3 times I times 4? Or what is going on here? It's, normally you wouldn't put the I in that position. So
Right.
I think it's a useful thing to use a more distinct syntax there and say, okay, this is a special format. It's similar to the engineering format of like 1E10. So that's 1J2, and that in the middle stands for a left out phrase. So 1E10 means 1 times 10 to the power of 10. And 1J2 means 1 plus I times 2.
Right. Yeah.
So those are the two reasons that I can think of.
That makes sense. What about the use of Greek symbols or Greek alphabet? Is that just are those just the symbols that were available, or
No, the Unicode didn't exist, right? Unicode came out in like 90 or something like that.
right?
And APL is from mid 60s. That was way before Unicode. No, they were free to use whatever symbols they could think of. The early APLers. But APL stems from mathematical notation. You've got lots of Greek symbols in mathematics standing for various things. You might not think of them as such, but say if you do a sum in mathematics, you write a large capital sigma,
Yeah.
and the lowercase sigma for standard deviation sometimes, right? And pi, you already know, but capital pi means the product of something, and so on and so on. Epsilon for a very small thing, but an open epsilon, the membership symbol, which means element of, or estis, or something like that in Latin, for is inside. So those were just carried over. So the membership symbol in APL is just the mathematical membership symbol. The row symbol that you discussed also actually came from the old APL. The Iverson notation didn't have multidimensional arrays, only had up to matrices. So it has scalars, vectors, matrices, and it used two different symbols for the number of rows and number of columns, and then those were Greek symbols, not to be confused with anything else. And then they switched it for the row symbol to mean both rows and columns and all other dimensions. But you can read it as row, but the function itself is called either shape or reshape, depending on whether you're using it with a left argument or not. So to reshape something or report its shape. There's no real reason why it should be a row letter there, but we want to keep it distinct. Right? So there are no reserved words in APL at all. And that means that everything that's built in has to have special symbols. And row being like the letter R, like the word reshape, it's easy to remember like that.
Yeah. But like you were saying earlier, you would say reshape, right? Like if you were saying it out loud.
I would say like that, yeah. And the monadic or one argument row, I would say the shape or dimensions of or the length of or something like that, depending on what exactly I'm doing. Iota is interesting. That's the index generator or integers, if you want, which fits nicely for the letter I, which is like iota. That name, though, basically nobody professional in APL says index generator or integers or anything like that. They always call it by the name iota. And that has taken on so much that other languages have introduced like range generating functionality, and they call it iota. as in like the name iota has become synonymous with generating ranges of numbers, even though it all comes from just APL using that letter to generate ranges. So I think it's really funny.
Oh, that is funny.
So now there are languages that don't use symbols that spell it out, IOTA, and it means generate numbers. But why that name? Well, because APL. So that's sort of circular. It's called iota because that's the right symbol for the thing that's the iota functionality. But it's easy to remember the integers. And alpha and omega for left and right argument, well, that's the leftmost letter of the Greek alphabet and the rightmost letter of the Greek alphabet. So that's easy to remember.
Makes sense. Yeah.
Alpha and omega. And I think that's about it for the Greek letters. Well, there's a del or delta, but you could also see them as triangles. An upside down delta is called the del or nabla, and del definition, it defines a function.
What can you tell me about the lamp symbol? I like that one a lot.
The lamp symbol. I don't know why they specifically who came up with that. I mean, once you get used to it, it's of course natural like any other symbol. And I think it was very forward thinking because it doesn't look much like a lamp; it looks much more like an LED, like with the two little pins coming out. But those didn't exist at the time. So and other people have said it looks like a thumb. So it's sort of like giving you a rule of thumb or something to remind you what the code does.
I can see that.
It doesn't really have connection to its similar symbols in APL. Sometimes the symbols are like related by glyph as well.
You can see it sometimes.
Yeah. APL Plus, the new version of APL Plus, so our Dialog's competitor, APL 64. I guess they're really proud of having gone to 64-bit finally. They have added 2 more comment symbols. So the lamp symbol is only an end of line comment. So from here to the end of line, sort of like hash in some languages. But there's no block comment, and they wanted to add a block comment or like even an inline comment. So they took that symbol and turned it on its side. So it's like horseshoes with a little circle thing. So it's like a sideways lamps, and then they can enclose a comment in the middle. I'm not sure that's the best idea, but hey, lamps everywhere. Apparently people like that. Then of course it's cute because it looks like those Among Us characters or R2D2. And some people see when they see it as well. So if R2D2 says you're my only hope, right, and giving you the information you need, then hey, the comments give you the information you need to enlighten you.
So my mind went to maybe like it's a lamp, like you're shining light on something, or like it's a signal.
That's the obvious meaning of it.
Like an idea light bulb.
Yeah. Any other symbols we should go through? There's a page on APL Wiki. I don't know if you've been in on aplwiki.com. There's a page with mnemonics where I've written down all those rules that my father taught me to remember all the APL symbols. I remember he made a bet one day with another APL consultant in England that he could teach me the entire APL keyboard, where all the shortcuts are for all the symbols in a short time. I remember if it was like 20 minutes or something like that. Or maybe it was 2 hours. I don't remember, but he won the bet. So I have these memory rules for where everything is located on the keyboard. Some of it is by shape of the symbol, some of it is by the meaning of the symbol, and some of it is like various word puns, but it works well. So you have like alpha and omega on A and W. Those are adjacent keys on a QWERTY keyboard, right? And they look like the symbols that they stand for. Comma, the comma button is where you find the comment symbol. So like comment works well.
Yep.
And some of the keyboard layouts are a bit interesting. Some of it is like historical quirks. The QWERTY keyboard, a standard US keyboard, is kind of weird in many ways. Some things really don't make much sense. I mean, it's just historical. You can't really change it anymore. But back then, when APL was new, there was no real standard keyboard. QWERTY, yes, but not where all the other symbols were. And so there are old APL keyboards that have certain punctuations are in different locations that made more sense. And what we use today is sort of a hybrid between that old APL keyboard and modern day keyboards. You don't want to move away things that people are used to, but we also want to preserve some of that nicety. So, for example, to type the equal symbol in APL, traditionally it was on the 5 key, not all the way over to next to backspace, like you know it.
Yeah.
And that's very easy because if you look at your keyboard, you've got the number row from 1 to 9, and then 0 is actually in the wrong place, right? Why isn't 0 to the left of 1? It's sort of odd, but it is what it is, right? So if you discard the 0 from not being in place, now you've got a row of 9 numbers, and if you want to split it into equal halves, you've got to do the cut on the 5, right?
Yeah.
So 5 is in the middle. That's also what people think of as the middle of the number line from 1 to 10 or something, even though it's not really precise. And then you've got less than or equal to is just to the left on 4, because it's like a little bit less than equal to 5. Mm-hmm. And then on 3, you've got less than, because it's like way less than 5. And the same thing goes the other way. So 6 is greater than or equal to, 7 is greater than, and so on. So there are all these rules for remembering the layouts and the combinations of things. You saw the up arrow is to take elements.
Yeah.
So another word for take is to yank, like to pull them. So that's on the Y key. That's how I remember it. And the opposite one, to drop things, is down arrow. That's on the U key, because dropping things makes them fall down under. So U for under, sort of thing.
Okay.
Okay. And those are next to each other too. Okay.
So actually remembering all those locations and all those special symbols it's the least of the problem once we really get into the language. In the Greek letters, no difference.
But I wonder how much thought they gave to like ergonomics when they were doing the layouts.
You mean as in like should be comfortable to type the symbols,
right? Yeah. Like the common symbols being on J and
on the
F.
home key.
Yeah.
I doubt it was much of a concern for a couple of different reasons. One is like you don't really type APL so fast. I'm not clever enough to type APL fast. I can move my hands fast enough, but I can't think fast enough. I can express myself in written APL faster than I can think what I need to do. So phrases I know well, sure, I'll type faster. But actually, back then, the way they would write APL in general was with IBM Selectric typewriter terminal. So it had a little like golf ball sized ball that had embossed characters on it. And it would hammer it. The sort of computer clever system would turn the ball in the right position so that the character you wanted was against the paper, and they would have like a ribbon of an ink ribbon, and it would hammer the little ball against the ink ribbon. And remember, I said that uppercase letters were changed into lowercase letters were changed into uppercase letters, and uppercase letters were changed into APL symbols. And I think they didn't actually move things around for that. They just substituted. So they had another requirement close to the North Pole of this golf ball, because it was attached to the South Pole, so to say. Close to the North Pole, there was very little horizontal width for each character, because there was the same number of columns all the way around. So the characters that were up there had to be narrower than, whereas the ones around closer to the equator could be wider if you wanted them to be wider. And so I would have thought that with this many restrictions on what you can do, ergonomics of the quick typing probably didn't come much into it. That's my thought, at least. And it has never been an issue. I don't think anybody got repetitive stress injury from typing APL itself. There's so little code you need to type anyway.
Yeah, when I envision someone programming APL, I don't imagine them just banging out tons of code. It's like thinking about a problem, coming up with an algorithm, a solution, and then coding the one line that you need.
Yeah. And I mean, lots of code is more than one line, but it's not. But yeah, I think you'll see APLers like thinking about every symbol that they're typing rather than thinking about every word they're typing.
Yeah.
And that's it. I mean, there were some one fun consideration of ergonomics was, I mentioned the J language. So if you look at your keyboard, the F key and the J key have little dots or lines or something on it. So if you touch typing, you keep your index fingers in those home positions. My understanding is that that when they came to actually give a name to the new language that Iverson and his people were working on, they needed to name the file. And if you're then sitting waiting for an idea on what to call it, and your righty, your index finger, which is your most easily used finger, is on the J key, so call the language J. That's it.
Yeah.
And then when Arthur Whitney went on to create the next one that sort of built on top of this idea, and then it would be K, right? Because it's just one over from the J key. It's a minimal movement of the fingers or something, or use the second finger in the row. So there's a little bit of ergonomics there, but not for the writing the language itself, I think.
I wonder, is every letter taken now? Like, I mean, not if you're thinking like
Yeah.
used languages, but there's got to be a repo out there for a language with every letter named, don't you think?
But what do you mean, that every letter on the keyboard or every symbol?
Yeah, like every letter in the alphabet.
Oh, so with the keyboard mapping, every letter in the alphabet is taken. Yes, but we have 2 symbols per the letter because you can use the shifted version as well. So, for example, with the E key and whatever APL method you have, like if it's a shifting key or prefix, whatever, on the E key you get the membership symbol, which looks like a letter E, right? Element of. And if you also use shift, you get an underscored membership symbol, which means something else, which means it's similar. It's not member, but it like finds the locations of things. So there are still some locations open in the shifted state. And I'm trying to be very careful not to burn characters, because I sort of think of it as a hard limit. Like once we've got 2 symbols, APL symbols on every key, all the number keys and punctuation keys and letter keys, that's it. We can't add any more to language. Of course we can, but then it becomes really hard to type. And I don't want awkward typing. I want easy typing.
Yeah. Right.
But there is somebody, an APL enthusiast, Madeline Vagani, has made something that sort of ironically is called Tiny APL. It's that goes on the implementation, not on the vocabulary. It's got a gazillion built-ins, and it's very difficult to type, I think, or do you need like multiple shifting keys to do it? So it's certainly possible to make an APL like language that has lots of built-ins. I think there's some kind of optimum somewhere. Like, you could say, can you make a language that has tens of thousands of characters? That would be absurd, right? If it wasn't for billions of people use, but billions of people use that kind of language every day, right? Like Chinese, and Japanese and other East Asian languages. Like, okay, maybe not billions, but at least 1 billion people are using that kind of thing. So, is it possible? Is it viable? Yeah, you could do that. Is it possible to make a language that has very, very few symbols? Yeah, but then you need more of them to express things. How many symbols do humans cope with on a daily basis without it getting awkward? That's how many different icons do you have on your phone? How many different traffic signals, signs, whatever, do you need to remember? How many can we handle and still be comfortable? It's an interesting question. Maybe someone can get a PhD on this. But you see in TriAPL, you see this language bar at the top, which have almost all the symbols that are in the language. The only ones missing are things like brackets, parentheses, braces, semicolon, and things missing from there. So, and how many symbols is that? It's like 80 symbols, and then many of them have like 2 meanings. It doesn't feel painful to me, but maybe I'm native. Maybe it's overwhelming for other people. The K language, which uses only ASCII, basically has the restriction of only using the symbols that are in ASCII. So it's like APL, no reserved words, and that means a very small vocabulary. They have to be very, very picky on which functionality to leave in. It does have a couple of exceptions where it uses like 2 glyphs together to mean something. But for example, there's a function in K to round down, but there's no function to round up. Like APL has both, because you can just negate and then round down and then negate again. So it's like a sort of a reduced instruction set. The J language also uses ASCII, but since they can't map APL to ASCII like that, they came up with a spelling scheme where every ASCII symbol can either be on its own or followed by a dot, a full stop, or by a colon, or occasionally by multiple dots and colons and so on. I don't like the spelling scheme. I think I can't parse it. My head can't tokenize. Parse it, yeah, I can't tokenize it properly. It descends into a myriad dots everywhere, and I would prefer to keep spaces between my symbols then, so to help me tokenize.
Yeah.
Some people say it works fine. For that, there are a huge number of combinations. So instead of like limiting themselves, Jay just went wild and added all kinds of built-ins that the APL doesn't have. It's an interesting, very interesting question.
That seems much harder to read just in my head. I don't know. I kind of like having the symbols that don't have an associated meaning in my head. They're only used for this one purpose in the language.
Yeah. I like that too. Some people have suggested making a like special ligature font for J that would take those adjacent symbols and tokenize them into some symbols for you. That's an interesting possibility. Other people are happy using J and they get used to it, I guess. They just see the groups and they know where things terminate. Always keep going to the right until you run out of dots and colons, I guess. And I mean, I see people dismissing APL for, that's unreadable. And I need to remind people that surely Korean and Chinese and Japanese are also unreadable, or any other Southeast Asian languages written in non-Latin letters, right? Unless you know how to read it.
Yeah, that is really interesting. A really interesting point. Because a lot of people argue that Chinese and those other Eastern languages are better because it's way less symbols. They can communicate like more densely, communicate more complex ideas and stuff. And I was thinking that earlier too, because I know I very briefly studied Mandarin. Don't ask me to say anything. I can say like 3 phrases. But I remember that in one of the lessons, they were saying that a lot of the symbols do have some historical meaning to them. Like originally, I think it was like the symbol for home was like was supposed to look kind of like a campfire, sort of. And you can kind of see it if you look at squint, but because over time, obviously, it evolves, the drawings and stuff. But it's almost similar in a way, right? Because in APL you see, some of these symbols that they have like the vibe of the thing that they do. You can see how the logic makes sense. You can really articulate it.
Yeah, I mean, I think it's very much the thing. Chinese, to a large degree, has sort of lost that connection. Like they use a lot of 2 symbols together to mean something, and not so much symbols on their own mean something in isolation anymore. APL obviously is a strict sort of non-evolving language, right? You don't change the meaning of a symbol over time; it stays fixed. And it's very clear that a single symbol means something. But there are phrases, like when we spoke about the ergonomics, there are phrases of adjacent APL symbols that you can learn to recognize as a whole thing. And you can then sort of see the beginning of that trend where you can read multiple glyphs that represent something very specific to be a word in a way, right? To be or a phrase, a compound noun or a verb in this case, to do something. And you can learn how to recognize that, learn to recognize patterns in APLs. It makes it possible for you to read it faster. Maybe you can see that, okay, here is some array that's being filtered by some condition. And maybe I can't immediately tell what the condition is, but I can see the overall structure of what's happening based on some patterns in the symbols that I recognize. So that's definitely possible. Right. You could also say that APL doesn't have types as such. It does in a way, but not like other languages have types. So you could say that there's sort of less meaning in the symbols themselves, and some of the meaning is in the context they're being used. If you use them with certain data, they mean one thing. If you use them with some other data, they sort of mean something else. They're doing the same thing, but the actual meaning for human is different. So in a way, you're moving some of the information away from the written language. And you could see a parallel to languages like Hebrew or even Arabic, where they only write consonants and not the vowels. And strictly speaking, you can't read it without the vowels, but any reader that's familiar enough with the subject matter, at least, or with the language itself, is able to fill in the necessary vowels to read it. So you've removed some of the information necessary for the reading into the head of the reader from the written text, and that makes the text very, very dense. You can fit much more in a smaller space. So that's again an interesting question, interesting study that I don't have time to go and find out about what's the optimal balance between information stored in the reader and information stored on the paper. You have it in English as well, like we said right in the beginning. English does not written English does not contain the information necessary for you to read it. You might think so because you're able to read it, but it's actually because your teachers or whoever taught you drilled into your head lots of stored information that you need to apply into the written thing to make it give any meaning. Because say the letter group OU or GH or one of those silly things in English, like you can't say strictly what do these letters mean on their own, but in the context they're in, you're able to fill in the missing information to figure out how you should read it.
Right.
You could write English in IPA, right, the International Phonetic Alphabet. Then it says exactly how to write it. Then the only information left in the reader is the mapping between symbols and sounds. You don't need to think. You just need to recall the information.
Yeah.
So why is that so awkward to read? There's too much information on the paper. Nobody wants that, unless you're studying linguistics.
Right. Yeah, there's probably a reason that IPA hasn't really caught on that way.
Yeah, nobody uses it for daily communication, as far as I know. Maybe some language geeks would do that, but there's no reason, right? You don't need to have that much information because people are intelligent. They can fill in the missing information. Just like on text, we put in spaces between words, but when we speak, if you really listen to what people are saying, especially in a foreign language you don't know, there really aren't any spaces between the words.
Yeah.
We're able to fill them in correctly. And occasionally somebody will come up with some funny phrase where you can't tell if it's one thing or another, and it makes the base of a joke.
I think we should just use IPA all the time, because then we can stop arguing about GIF versus GIF, or what's another one thing people argue about? How to say caramel or caramel?
Neither, neither, tomato.
Yeah.
Root and route and so on. And but again, the information density would be so extreme, it would be really awkward. And can you imagine handwriting English like that? It's horrible.
Not at all.
I can't imagine somebody writing an algorithm by hand in say Python. Like that seems like an unbearable burden to write. But writing an algorithm in APL by hand, yeah, sure, we do that. At our main office in England, we have a blackboard, one of Iverson's old blackboards, and we regularly sketch out things in APL on the blackboard. There's plenty of space because there's so much information that doesn't need to be there. Right? There's no information about how the sorting is implemented or how you search for something. Is that a binary search or a linear search or whatever? We just say, a search, and then leave that to the implementation. How do you actually find it?
Yeah, if I was whiteboarding something like that in Python, I would probably write in words binary sort, and then move on to the next thing, to whatever I'm trying to say. Right. Well, Brendan, do you have anything else, or?
I don't think so. That's it for me.
Yeah, there were some questions you asked in your podcast that I wrote down. I don't know if you want me to go through the things we haven't addressed. Are you interested?
Sure, yeah, let's go through it.
So you mentioned the thing about the high minus. Why does APL use a high minus for negative number or a different symbol for negative numbers? Remember that in APL you can write a list of numbers just with spaces in between. If you use a normal minus symbol, you couldn't tell whether you're subtracting one list from another list, or whether one of the middle numbers was a negative number. And otherwise, you would have to introduce interesting rules like, there has to be spaces adjacent to the symbols. But generally, APLs don't write some spaces between their symbols. Okay. And so that would sort of be disruptive. And as you mentioned also
Nice.
correctly, it's nice to be able to distinguish between the negation function and the number's property of being negative. Another problem would be in, say, the engineering format or in the or in the complex number format, right? You want a negative symbol that's part of a phrase of characters that is one number. So, for example, if it said 1e minus 10, right, then it's 1 and e, and then you're subtracting 10 from 1 and from e. But by using a high minus, 1e high minus 10, you can see that it continues and it's one big number, 1e negative 10.
Okay.
That's neat.
So it's really necessary for the parsing. You asked what is the difference between functions and operators. So in APL, functions are what you would call operators. Primitive functions, the symbols are what you call operators in other languages, doing things like plus or minus and those things. And operators are higher order functions. So I don't know if you're familiar with those. In functional programming, you've got things like map and fold and those things.
Oh, okay.
And those are called operators. So basically, an operator in APL is an entity that takes one or two parameters that are often functions, but could also be arrays, and derive a new function. You could see them in a way as function factories. Right? So the reduce or fold operator takes one parameter, which is a binary function, dyadic function, so say plus, and produces a new thing, which is summation.
Okay.
So a lot of the power of APL is really through the operators, of which there aren't that many, but they're the ones that are very powerful and that you can do things. So
yeah, that's cool.
Then you had a problem with applying conditional logic to an entire array.
Yeah,
so
I was still confused on that one.
Yeah, so that was, you can do this. We have something called each, which is like for each in some other languages, which is a higher order function so an operator that takes a function like the one you wrote, and then you just map it. That just does the mapping for you. But an APLer wouldn't want to do that. If you want me to, I can share my screen. I can show you just briefly how you would do things.
Yeah, go ahead.
So let's see if I can do this. Screen, and we can do this one. Okay, so this is not TriAPL. This is the full installed APL system, and that on Windows.
Is this RIDE?
So this is not RIDE. RIDE is an HTML kind of cover for the interpreter or front end for it, which I could use here on Windows, but on Windows there's also a native front end that the interpreter has.
Cool.
So this is what's happened. So I don't remember exactly what it was you wrote, but let's say we have some numbers here and some other numbers here, and we want to do a condition. So we can say if the left argument is greater than the right argument, then we can return left. Otherwise, we return right. That was a little bit of misunderstanding as well, that this is not really a ternary with these two symbols. What's actually happening is the diamond is a statement separator. I like to say that it's because nothing can sort of traverse a diamond, so like diamonds are unbreakable. And this is a guard. This is like an early out. So really what's happening here is it's a little if statement that says if alpha is greater than omega, so if left argument is greater than omega, then do an early out and return left. Otherwise, continue. And we can have many statements after that. And then we can have more such guards that say, oh, if this condition holds at this point, then quit with this value over here. It's very nice for functional programming. Things like, factorials and Fibonacci numbers and things like that.
That makes sense. Yeah, I was confused in other tutorial about why the diamond was also the statement separator. That makes sense.
Because there's no ternary here, but you can use it as the ternary. Right. So this will fail. Why? Because remember, APL is array oriented. So when we apply this function, then it's applied with this entire left argument and this entire right argument, and that's when you got that error message. And what you didn't pick up, it seemed, was that this little caret here points at the problem location. So it said when we were to evaluate this little if statement, this guard, then we needed a Boolean singleton. We need a single Boolean value, true or false. I can't both return here and not return here with this value. You can't give me 3 Boolean values. So we can actually insert a little bit of code here to spit out the intermediary result that we get here. You see that it says 1, 0, 1, right? 3 is greater than 2, and 1 is not greater than 7, and 4 is greater than 1. That's not a proper Boolean value. So we can add, this might seem funny, that's so little code necessary, but these 2 little dots here, I can make this a little bit bigger for you. So these 2 dots here, I like to think of them as like, do it for each little dot. So rather than on the whole array, do it on each element of the array. Then we get this, right? Left, right, left. That's what you were missing.
Okay.
However, that's not the APL way to do it. We don't like to loop over things. We like to do things directly on whole arrays. So if you go back to this, right? Now, by default, APL traditionally uses one based indexing, and you might be used to using 0-based indexing. So let's just say that this is a special system setting. We're saying that the indexing origin is 0 rather than 1, right? And now remember that Boolean values don't really exist. These are just numbers, which are just indices. So we can use this to index into an array. So if we say that if it's supposed to give 0, if it gives 0 here, the first element, then it's supposed to say right. And if it gives a 1, that's the second element, then it's supposed to say left. And then we can index using a whole array. So when we use indexing with brackets, like in many other languages, it doesn't have to be a single index. It can be multiple indices, and you get an array back, 1 per index, 1 element per index. And these 2 words are just, again, separated by spaces. It's just an array of 2 words. So in one swoop, we get the whole thing computed. There's no looping going on here, or at least no looping that we can see. But of course, inside the computer, it does the necessary looping. But this is also much more efficient than setting up a loop.
Oh, that's cool.
Right. Of course, if let's say that these were not words, let's say we wanted to return some values. So let's say that, for example, we wanted to return 4 and 2. Right? You might think that, oh, this is a nice way to do it. This is, again, not how an APL would do it. If we go back to the Boolean values here, so then we can see that we want to map 1 to 2 and 0 to 4. So I would use some mathematical method of doing that. So if we write 2 times this, because these are just numbers, we get 2, 0, and 4. How can we go from here to here? Well, if we subtract these numbers from 4, then we get the right thing we want. So this is how an APL would do it, or something similar to this. This is, about, of course, a bit of a silly toy example, but rather write a mathematical formula that gives the right result than writing an explicit mapping or even looping that does what I want.
Wow.
Can you tell me a little bit about your background in terms of mathematics? Because there's this feeling that I get when I look at this stuff that, like, yeah, I just don't really have the background to think about things that way. Like, I feel like I could sit down and really spend an hour and like figure out how to do this, but I feel like maybe it's just from programming APL, but I feel like you also have a strong background in math. Is that right?
I mean, not really as studies. I went to high school, and at high school I took a university course in linear algebra, but that's the highest mathematics I've studied formally.
Okay.
Other than that, it's just been the APL, and that's just about where APL stops as well. It doesn't have really built-ins for much more advanced that you would get to throughout school and taking all the math courses you can and some linear algebra, and that's it. But it is a different way to think, and it takes time to sort of think this way. I'll show you 2 more steps that we can do here, and just to see how things would go. If I take this now, because these are just values, I can move this out over here. So now we got 4 minus 2 times, and then remember APL has long right scope. That we spoke about. You spoke of that in your podcast about the order of execution. Everything is very simple. So everything you could say goes from right to left, or everything has long right scope. So now we've sort of isolated out the real moving parts of the comparison, and then the post-processing is just adjusting those values to the values to become the values that we want. But now you should be able to spot something. We have this little custom function here that all it does is take a left argument on the left and a right argument on the right and compare them. So this custom function is, of course, completely equivalent to the built-in comparison. Now our code is much cleaner. There's no user function here. There are no moving parts. It's just the mathematical formula.
Yeah.
Wow.
That's cool.
So we want to keep things simple, lightweight, no layers, no unnecessary abstraction. We just write things as they are. There's no reason to give any of this a name, right? Because you just read what it says.
Yeah.
It's just simple math.
So that
Whoa.
maybe that's a good example of like how does debugging work when you're doing this stuff? If things aren't working the way that you want in APL, you kind of showed that little operator to output the intermediary result.
Yeah, you could do that, but there is an interactive debugging as well. So I can show what that looks like.
Sure.
I can. So there's interesting thing is that the language itself, like as I said, it's sort of like a shell that I live in. This REPL interactivity and everything happens there traditionally. Today there's some cool kids that want to do scripting outside the APL, but traditional APLs, they work inside the APL system all the time. So here's a function, a built-in function, ed stands for edit. So it's a normal function that I can apply with higher order functions. I can use it inside my programs, but it is an integrated part of the development environment. So I can make a function called foo just by calling this function with the argument of the text foo. That opens up my editor over here. So this is, now we've got an editing window over here, and I can define my function foo here. So we can make some intermediary variables. We say x is omega omega, so 2-element list of whatever we gave it as the argument, and y is something with 3 elements based on the argument, and then we can return the value x plus y. So you probably see the issue here, that we're going to get a length error eventually. And now I can either save this as it is, or I can close the editor and save it. So we can do that, yeah. And right now things are just living in memory. There's no file representation of this, but I could set it up. That's probably too much to cover for right here. Now, if I run foo with say just a number 3, then we stop inside the debugger tracer. And this is interesting because this kind of functionality, while not exactly like this, because there were no screens back then, has basically been there from day one. But then you would instead like print things out on the typewriter terminal on the paper. But I can go in now while the function is suspended and edit things. You can say, no, I don't actually want plus. I just want them made into a list like this. And then I can switch back into execution mode, and the function that's on the stack here was changed. And then I can say, yeah, continue. We get the result like that. So this is the basic way that I would debug normally in APL. I would run the code, it's stuck with a problem, fix some of that, continue execution, hit another problem until it works. That's one way to do it, at least.
So do you normally write your functions like on multiple lines like that, and then the real compact first version, no spaces and everything, is like kind of a final.
I don't. I usually write my APL code is very airy, very lots of extra white blank lines and very short lines of code, like very tall code and lots of space for comments on the right.
Oh, okay.
I don't see a need to write my APL code in a especially dense way because it's already so dense. So I do a lot of sort of systems programming, not very much algorithm things, but if you see some of the code I write, it doesn't look so APL-y as you might think APL code looks like. When you look at examples online, they are all often like dense algorithmic things. this is some system code that we run when we start up the APL system. So some bootstrapping stuff. And it looks much more like programming that you're used to, right? With indentation and control structures and so on. And then inside that, you've got some dense APL phrases for when I actually need to manipulate arrays. So it's sort of a mixture. I like to layer my APL code. So I've got this imperative code on the outside that's running the main program loop. And then I've got some small, this one's maybe not the best example of it, but I might got some small of these brace functions that you see here. These are examples of inner functions that I've defined. Those are small utilities that I need in my big imperative program. And then inside those, I might write tiny little dense functions or expressions, sort of the lowest level that does the real meat of the of data manipulation.
That's really helpful for me. That helps me understand like how you would use this in the real world, is to put together a program. Is you have these chunks of APL that are like these dense little nuggets down in the buried in the inside the program.
The problem is that the things you'll find online will often be like code golf, like competition for short code and lead code things, and people will write all these dense things, but that's really that lowest level thing that I personally don't write much of, because I deal lots with these system things and helping people with various tools and things. But there are things like that. If we go to let's see here, format text. So this is this one. This is some code to lay out a paragraph of text with some indentation and hanging indents and things like that. You don't see so many APL symbols, but it's still quite dense. To try to make it readable, it sort of has these very short lines that just does one thing at a time. And this is another interesting thing of APL, that if you don't know what the symbols do, you can still sort of get an idea, because the only words that are left when you don't read the symbols are the words that the programmer made. And if they choose the names right, it should give you an idea about what's happening. So you can see, you don't know what the specifications are, but you can see that I'm getting something in here with the left and the right and the first line, some indentation there. You can see that I'm doing something with some hanging indents on the first line and some leading text, and then we're building up the main text. You can probably figure out these are carriage returns and so on, even if you don't know exactly what the symbols mean. So this is a good example of some dense code that doesn't use a lot of symbols. The code up here, you got some really dense code that does use a lot of symbols. Here's an interesting thing. It happens to be this exact phrase is one of those phrases that experienced APLers will just read the whole thing and know exactly what it does, because it's such a common thing to write. And having you can see if you can come up with a good name for this. So I can tell you what this is doing. It takes a matrix of characters, so a table of characters that represents a text, multi-line text, and then it cuts it into individual strings, one per line or row of this matrix, and then it removes any trailing spaces that were padded because the matrix had to be orthogonal. Okay? That's this. Can you come up with a good name for that functionality that is shorter than the implementation? And this isn't even the shortest implementation of it that could be written. This is just a common way to phrase it. Right?
Yeah. No, very, very compact, very unambiguous.
Or
row trim.
These characters here, this is round off to closest integer, tie breaking at 5 to round upwards. Right? So normal rounding, but there are many different ways you could round. But this one says what it does on the tin. If you just said round, you wouldn't know, is it banker's rounding or is it right? Is it random rounding? Is it what are the many different rounding algorithms? Round down, whatever. round to nearest even, nearest odd, round favoring away from 0. There are so many different ways you can round. But all this does is you add a half and then you round down. So it does exactly what it says in the tin, right? Because if you have 0.5, you add 0.5, you're up to the next integer, round down, you don't move. Anything else rounds down.
Yeah, that's a good one, because that's something you run into. There's a function called round, and you have to just know what it does, basically.
Yeah, or I think and there's a Python method when you're dealing with decimal where you get to specify, and then you get into, now your round function has like multiple arguments, and
Yeah.
you can complicate it.
And this is 5 characters. I mean, you can spell out the word round, but it will be the same length, so why even bother?
Right, yeah.
Anyway, if I stop that, got away from the questions we were on the way through. If you still have time,
Yeah.
taking time here. You asked, why do you need to know an array's depth? So this is something, it's not the most common thing to do, but occasionally I might want to process a tree structure. So arrays of arrays of arrays. And I want to know when I reach the bottom. Then I need to know the depth I'm at right now. So I would recurse into each element, and then I will check at every step what is the depth of my argument. It doesn't have to be all the way to the bottom. It could also be, I write a utility function that operates on, say, arrays of depth 2. So for example, an example of an array of depth 2 is a normal text that consists of a list of strings, so a document. So I have a function that can only work on that. It doesn't understand higher structure, but I have now a lot of text in some bigger structure, and I need to apply this text processing function on each sub part of the array that has depth 2. So then I would recurse into the array until I find something that has depth 2 or less, apply my utility function, and continue.
Okay.
So I need to know the depth for that.
Makes sense. Yeah.
Then you asked, what does it mean to rotate on various rank? That was, I think that's the last question I have. I think the easiest thing for me to do is to share my screen again. Yeah. Okay. So let me first write. Yeah, we can do it like this. Maybe we should make it a little bit bigger. 4 or 5 reshape. So quad A is just a short name for the uppercase English alphabet. So this gives us a 4x5 table of letters. And we have got a shape for this, which of course is 4-5, right? 4 rows, 5 columns. This means that the shape of the shape is the rank. That's the number of dimensions.
Okay.
And we can rotate one step. And we can either rotate the first row to become the last row, or we can rotate the first column to become the last column instead. And so there is a higher order function, an operator called rank, which uses this little frowny symbol. And you can, well, actually use this other rotation symbol. This will work better. Okay. And it can then specify at what rank do we want to apply the rotation function. So if I say I want to apply the rotation function at rank 1, so rank 1 is a list, a vector, so that's a row of the matrix. So, sorry, I shouldn't have did the reshape here. Right? So on every row, we took one element from the beginning and rotated to the rear.
Okay.
If I apply it on rank 2, that means I apply it to the entire array. Then it means I took an entire row and moved from the top to the bottom. So we're applying this function on different ranks.
I see.
Are we applying it? It's sort of, I think of it as, I don't even know what they're called. You know, when people go on a horse, they sometimes put these little things on the sides of the horse's eyes so that it shouldn't be distracted by traffic and other things. So they only look in one direction.
Blinders.
Blinders, yeah, blinders are called. So I thought, sort of think of it as this. This here, it restricts what this function can see to be subarrays of this rank. So this means, in this case, no restrictions because the array only has rank 2. So we can actually get rid of that altogether. We don't need parentheses at all. Whereas this up here, it restricts it, so it only gets to see one rank 1 array at a time, so one row at a time. If we make 3, 4, 5 reshape the alphabet, so then we can take an entire layer and rotate to the bottom instead.
Oh,
Or we
right.
can, right? Or we can rotate matrices. This means we're rotating one. Oh, sorry. Did I do the right thing? Oh yeah, because it's just repeated. It's a little bit hard to see because you've got the same. Let me start over here with. Now we got a little bit better here. Maybe we should even do the digits at the end so we can sort of see the whole thing. So these are our 3 layers, and we rotate one layer to the bottom, and this allows us to rotate each row, the first letter of each row to the end, and then we got the middle dimension. You can rotate, and in every layer we rotate the first row to be the bottom.
Wow.
Yeah, that's
Wow.
crazy.
Yeah, if you were to write this in a loopy language, you would write a bunch of for loops inside each
Yeah,
other.
you're writing a lot of code just to do that.
Yeah.
But there's this is what it means to apply with a rank. There's some legacy way to do this without the rank operator as well, but it basically is the same idea that you're applying things along the various dimensions of your array, and you can do that with pretty much anything. So if we say 2, 3, 4 reshape iota 24, so this gives us the numbers from 0 to 23, right? Because we generated the indices, 24 indices, and then we reshaped them to 2, 3, 4. So we have the higher order function of fold or reduce, so that, and with a function plus, so this sums along the rows. We actually have a built-in shortcut for summing along the first dimension as well. So 6 here, that was 0 plus 1 plus 2 plus 3, right? And so on. 12 here was the 0 plus 12, and then 1 plus 13, 14. And with this one, we can then use and restrict it. So this one wants to go always to the last dimension. This one will go on the furthest out they can say and just collapse layers on top of each other. But if we restrict it, we can say, well, do operate on arrays of rank 2, then we get 0 plus 4 plus 8. So we're summing down the rows of this table here. That gives us the 12. And we can do it rank 1, and then we get the same result as up here, where we're summing each row separately. No looping in sight. Okay, well, maybe I should leave it here. You can go punt to this.
It's kind of beautiful.
I think it is.
I think it's like once you get your head around it, it seems incredibly powerful.
Yeah, it really is. It allows you to express yourself to the computer for what you want, and be more focused on what it is you want than how to tell the computer how to do it. Right? I don't need to think about for loops here, or edge conditions, or the starting element, initializing a counter or initializing an accumulator that I need to add to. All of that just completely disappears.
Right.
Just focus
that
on what I
goes
want.
back to what you were saying about like your idea of why LLMs might struggle with this, right? Because we're not trying to figure out how to put it into the computer, right? We're just solving the problem. So the LLM can't really just solve the problem for you, right? It can give you
there's no way for it to guess whether I want a 1 or a 2 here, right?
Right.
It just can't. Or if I'm interested in the product, in which case the only thing I need to change is the multiplication sign instead of a plus. Right? How would it not possibly know that? And trying to explain that to more effort than it's worth, and I can just express it like this. So yeah, it's I find this is way more comfortable, and even without any words. But you can make it wordy. So we're even allowed to take like sub parts of the syntax and give them names. So we can write a new higher order function, so a new operator called onRows, and I'll define that as being this rank symbol with a 1. Okay? So this was a higher order function that takes 2 parameters, the product here and the specification of the rank. This already has so to say the slot on the right is already filled, so it only needs 1 more parameter, which is the function you want to apply. So now we can go and say, I want the multiplication applied on rows. So if you think that's easier to read, then sure, you can do that. But on rows with the extra space necessary over there, that's, what was that, 7 characters or something like that, when I could just write these 2 symbols and call it a day. So eventually, you really don't want that anymore.
I was wondering about
Yeah,
that
no.
though. Yeah. Seems like it's good.
I was
that
going to say,
you're
I
able
mean,
to do that.
I'd argue it's almost even more vague, right? Like, what does on rows really mean? But I
Yeah.
know what that symbol means.
Well, what happens if you apply on rows on something that's only a single number or on the list or that doesn't really have rows? Yeah, whereas this is very simple. This means restrict the application to subarrays of maximum this rank. So we just read that as multiplication reduction rank 1. But you could use names for things. Like you can say times, and we can say reduce, and then we can spell it out. Times reduce on rows. Is this more readable?
Yeah.
Yeah.
I would venture to say it's not. It's not worth it. It's way more typing and bigger chance of making a typo that you need an LLM to catch and fix. I don't need that. Good. Any other questions? Or maybe we should round this off.
No, I think that's great.
Yeah, I think it's a pretty good stopping point. Yeah, thanks again, Adam, for coming on. I don't know. Do you want to? Do you have anything you want to plug, or like where can people find you?
I mean, I'm not that important in my own. Finding resources about the APL, I think you just search in any search engine of your choice, or type into the LLM of your choice. Any question about APL? I think we're pretty good in being able to find things. You mentioned Try APL and Dialog's website. I would recommend, if you really want to play with APL, then download it, install it. As I mentioned way early on, that it was like traditionally commercial thing, but already quite a few years now, Dialog makes the full product available for free. To as long as you're not making a significant amount of money on it, and there's like a default license, so that you only have to pay something if you start making a large amount of money. I think it's like €5,000 per year or something like that. If you then we ask for some percent of that, or negotiate this contract with us. But anybody, and like for what's called like not-for-profit users, organizations, schools, whatever, education things, playing around, hobby project, that's just free. You can just do it, and there's no calling home or checking your licenses or anything like that. It's just so I think it gives a much better experience than doing the online thing. You have the whole full screen editor and interactive debugging and all those things.
Right. Yeah.
And then for those that are curious about APL, then the APL wiki. That's definitely what I would recommend. And if you really want to know about me personally, you can find information about me on APL wiki too.
Yeah,
there are lots of links to resources, both learning resources and community things, events, and so on.
Awesome. Yeah. Well, again, thanks so much for coming and showing us all this stuff, man. It's really interesting, and I want to dig more into it. I want to try and make some time to do some more dialogue APL coding.
Absolutely.
Oh, you're always welcome to reach out with any questions, and you can always find me. Actually, that's maybe one thing I could say. If you have a Stack Exchange account and you have gathered any reputation at all on Stack Exchange, then you have access to a chat room where I'm always at on Stack Exchange, and you can find it easily by going to apl.chat. And if you don't have access there, then you can send an email and we'll get you access
Cool.
as well. So if you have any questions at all, want to discuss, like why is it designed like this, and why can't you do like this? These are questions often come up, and then there's always somebody there to answer a question fairly quickly.
Awesome.
Okay.
Awesome.
Thank you so much for having me on.
Yeah. Thanks, Adam. That was so
It's been
much
really
fun.
enjoyable. Take care.
See ya.
Bye.
1x Developer Podcast.
Hey everybody, this is Colin. First and foremost, I want to thank you all for listening to this episode of the 1x Developer Podcast, and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1x Developer Podcast. We're also on YouTube at 1x Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1x Developer Podcast. Thanks so much. See you next time.